Log into almost any online course, navigate to the discussion board, and you will likely find an environment characterized by isolation. Students type out disconnected blocks of text, submit them into a digital void, and log off. It is a common assumption in instructional design that placing learners together in a shared digital platform will naturally yield social interaction. The logic assumes that proximity equals connection. But students operating inside these unstructured environments view peer feedback differently. They treat replying to a classmate not as an opportunity for collaboration, but as a transactional task required to secure a grade. When designers fail to explicitly structure these spaces, learners default to superficial compliance. They post the minimum word count required, entirely missing the opportunity for higher-order knowledge construction. Passive digital proximity only guarantees isolation. If you want genuine academic debate and connection, you have to engineer it. This diagram shows the architecture of an online learning experience. Notice the physical white space between the central learner and the outer ring of social interactions. Engineering connection across this gap requires generating digital co-presence, the psychological illusion that separated individuals occupy the same space. Creating that illusion requires deliberately establishing two elements. First, intimacy, which in a digital setting means emotional transparency. Second, immediacy, which relies on the strict, predictable timing of responses. In a physical classroom, you don't have to think about this. Nonverbal cues like eye contact, physical proximity, and facial expressions handle intimacy and immediacy automatically. In an online environment, the platform itself cannot do this work. True digital interaction requires instructional designers to build invisible scaffolding that actively engages a learner's cognitive, behavioral, emotional, and social dimensions. Effective digital social interactions rely heavily on the interplay of 5 specific structural factors. The first factor is the learning objective itself. The strict goal of the lesson dictates whether the interaction requires a learner-instructor dialogue or a learner-learner format. Second, the required levels of intimacy and immediacy dictate the technology. A debate requiring instant pushback needs synchronous tools, while reflective synthesis thrives on the time delay of asynchronous forums. Third is the technological context. A learner's prior experience and psychological attitude toward the platform itself introduce friction that designers must account for. Fourth, you have structural interaction attributes. Asynchronous discussion threads, for example, quickly overwhelm participants when group sizes grow. Once a thread exceeds 5 members, productive conversation fractures. Finally, specific learner characteristics. Variables like cultural backgrounds or age directly alter a student's preference for collaborative group work versus competitive independent tasks. If you ignore any of these 5 factors during the design phase, a planned community building exercise degrades back into a transactional chore. To carefully bridge the gap between isolated content consumption and actual debate, instructional designers rely on formal instructional framing. This is executed using a pedagogical wrapper, a cognitive and motivational primer presented to the student immediately before they begin a collaborative task. The wrapper serves 3 core functions. First, it makes the instructor's exact purpose explicit, directly connecting the upcoming discussion to subsequent course objectives.
Second, it cognitively prepares the learner by grouping the specific reading materials or reference data they will need to construct a valid argument. Third, it establishes highly transparent performance criteria. It mandates rules of engagement, such as requiring cited evidence from the literature or forcing a response to an alternative perspective. This structured primer prevents learners from walking into a discussion blind, which is the primary cause of superficial "I agree" replies. By acting as a bridge, the wrapper ensures learners possess the exact why and how of their collaboration before they type a single word. Once these wrapper-driven interactions begin, how should the instructor manage them? A pervasive assumption in the industry is that a high frequency of instructor posts directly equates to a better learner experience. The data shows the opposite. Overwhelming instructor involvement actually constrains peer participation. If the instructor answers every point, they shut down organic student debate. The optimal approach relies on facilitated, guided communication. The instructor sets the parameters early and then strategically steps back. To maintain academic rigor without constant policing, you deploy interaction rubrics. These serve as invisible boundary lines that establish cognitive, behavioral, and social expectations. A well-designed rubric defines strict parameters. It requires learners to synthesize ideas collegially and challenge assertions with evidence, shifting the focus away from simply hitting a minimum post count. By intentionally calibrating instructor presence and relying on strong rubrics, designers empower learners to take true ownership of the intellectual space. Maintaining this carefully engineered co-presence requires integrating learner involvement into the macro flow of the entire course timeline. This starts by deploying asynchronous, free-flow discussion areas. These spaces are designed strictly for proactive, formative feedback, giving students a direct line to provide input on the course layout itself. Next, you reconfigure virtual office hours. Instead of hosting an empty waiting room, you assign a specific, purpose-driven topic to the session, transforming it into a high-value interaction. When courses foster high involvement, learners often find it difficult to disengage at the end of a unit. A dedicated debriefing area allows them to reflect on the learning process, share observations with classmates, and reach formal closure. These structural touchpoints give learners continuous agency over their digital environment, preventing engagement from stalling out mid-semester. Let's return to the core diagram of the online learning experience to view this system in its fully engineered state. Look at how intentionally designed social interactions act as the connective tissue. They sit on the outer ring, directly linking static learning activities with formal assessments. This optimized outer scaffolding successfully drives pedagogical energy inward. It activates the cognitive, behavioral, emotional, and social dimensions of the central learner. True digital connection is never an accident of software. It is the direct result of applying pedagogical wrappers, clear rubrics, and calibrated facilitation. This intentional architecture forces the learner to abandon the transactional, check-the-box mindset that plagues standard discussion boards. By engineering digital co-presence, instructional designers shift the student's experience from isolated task completion to a social environment where knowledge is built through collaborative dialogue.